Have you ever wondered how do delivery apps like Zomato and all give you such an accurate delivery time estimate? Well, we will find out the magic behind it in this video. Before we get started, I want to tell you that I read about this on the internet and found it very interesting. Therefore, thought of sharing it over here. The observations and algorithms that I will be sharing are based on the implementation of a US company, Postmates, and the article that I read will be linked in the description below. So with all of this out of our way, let's get started. The problem here is we want to accurately find out how much time a delivery person would require to deliver the order to the customer. Every one of us wants to know when our food will arrive right after we place the order, isn't it? Or even better if we can know beforehand, right? But never had I imagined that the algorithms and challenges behind a problem that looks so simple can be so complex and extremely interesting. At first sight, it seems knowing the distance between the delivery person, merchant, and the customer can be enough. But it's just the beginning of the story. There also comes in food preparation time, which has to be given a big consideration. So the first step any company has to do is understand their data. And the few information that can be handy are distance between merchant and customer, distance between delivery person and merchant, food preparation time, and the kind of vehicle delivery person is using. But soon we can realize that these are not enough. The main challenge of this company, Postmate, was that they wanted to provide the estimated time before the customer places the order. So obviously they cannot know the position of the delivery person or the vehicle they are using. Apart from this, complications like more traffic than normal, merchant busier than usual, difficulty by delivery boy to find the parking, difficulty in finding customer's address may also occur. Basically, you never know what is going to happen, and complications like these are very common and bound to happen. So whatever model is prepared must be independent of these challenges, and this is itself a challenge for this problem. For the initial stage, they found out that the data they have is extremely noisy. What does that mean? Observe this delivery time versus distance graph. We can clearly observe that there is no consistency or any kind of flow. You basically cannot draw any conclusion from this. So the next step they went for was modeling. Or we can say try and extract something from this data. They found out that the data needed regression modeling, but they started with something simpler and used linear regression with only one feature, because time and resources are very limited to teams according to the writer. This is the outcome they came up with. So to test the effectiveness, they used 10-fold cross-validation to train the model and evaluated it using mean absolute error. What do these mean? Cross-validation means partitioning the original sample into testing and training set. What happens in k-fold cross-validation is the original sample is randomly partitioned into k equal size subsamples. Among the k samples, one of them is kept for testing and others are used as training data. On the training samples, the cross-validation is repeated k times, with each of the subsamples once as the validation data. The k results from the folds are then averaged to produce single estimate. And all of this process gives us an average error, that is the time estimates are off by this many minutes on average. For Postmates, the MAE, mean average error, came out to be 9.79. This means that their time predictions can be off by approx 10 minutes in an average. Looking at it as a general individual looks pretty good, keeping in mind all the challenges. But is it good enough for a company who wants their customers to be satisfied with them? Well, no for Postmates, and they went ahead to improve this result. So they cleaned their data. Initially, they had used start and end timestamps that were recorded, but they found out using the GPS coordinates of the delivery person would be more accurate feature, and it proved to be correct. They removed a lot of noise and their new mean average error came out to be 8.78. The writer of the article has mentioned that understanding the data played a big role over here. After this, they thought how can this model perform better, and then came in the role of food preparation time. They started collecting the average time needed to prepare an order at different hours of the day for each merchant. And now they had a graph with linear equation fitted to a two-dimensional set of points. This is multivariate linear regression. And from this data, it was clear that merchants with higher prep time generally have higher total delivery time, which is very obvious. So after adding this feature, their MAE came out to be 8.02. After this, they added a third feature to their model, and that was taking into consideration the traffic at different hours of the day. They took the average travel speed of different delivery person using cars at different time of the day and added this information to their model. Now incorporating this was no rocket science, but it just gave an improvement of making the MAE from 8.02 to 8.01, which is not very helpful. This happened because the travel time doesn't really vary. It remains quite the same throughout the day, and also this feature was indirectly added while estimating other features. This was still not a satisfactory MAE, so they decided to add another feature, the delivery person waiting time. By real-time data collection, they found out that a delivery person required approx 10 minutes to park, pick up the food and head out. This is a plotted probability mass function for average wait time per merchant. It looks like Poisson distribution, but more accurately it is a Gaussian distribution with no negative values. What the graph shows is that some merchants have higher wait times on an average, and the major reason can be that parking might be difficult in some area, or the actual food preparation time may be more than what they have reported. So this turned out to be a very good feature and was incorporated in the model to achieve a MAE of 7.40. So finally, they had a fairly good estimate of error, and they could assure their customers with delivery times with just an error of 7 minutes and 24 seconds. This is the story behind how your food gets delivered inside the frame time given to you. I hope you liked what we presented to you today, and it would be so awesome if you could like this video and subscribe to us. Also share this video with all those geeks who might be curious about this. Thank you and have a nice day.